get started. Okay, so a set is an irrational number. So any number that has got the square root sign and you can't determine that square root or cube root or fourth root or fifth root is called a set. Now there are two laws that you need to be aware of. Okay, the first one, it's a multiplication law, and then you also have a division law. Right? So if you are given any set, okay, like say the nth root of A times the nth root of B, okay, if you multiply those two sets, you end up getting the nth root of A times B, okay? So when you are given the nth root of any set, now when you say the nth root, it means that this n here is going to be the same. Okay? If you have got different numbers here and there, it means that you cannot use that multiplication law. The multiplication law can only be used if the n is the same. Okay? Also, if you are given the nth root of a product, like in this case, the nth root of A times B, you can split it up and write it as the nth root of A times the nth root of B. Now, those two are part of the multiplication law. Okay? And you can only use the multiplication law if the n or the root is the same. Okay? Then for division, they have the nth root of A over the nth root of B. This can be written as if you are dividing the A and B and then you take the nth root. So the nth root of A over the nth root of B is going to be equal to the nth root of A over B. Furthermore, if I give you the nth root of A over B, you can also split it up and write it as the nth root of A over the nth root of B. So those are our two laws, that is the multiplication law and the division law. They are extremely important when you are dealing with sets. Okay? Okay, so let me do some examples. Okay, it will be better if I do some examples, then you can be able to understand it more. So I'm going to do some examples. Right, so I've got two examples from the Mind Action Series textbook, that is exercise 5 on page 9. So I'm going to start with the first one, okay? So I'm going to start with simple ones, then I move on to complex ones. Right, so here we have got the square root of 7 times the square root of 3. Okay? We just have to use the multiplication law. Right? The n is the same. It's not written. I'm sure you are aware that when you've got the square root, we don't put the 2 outside the square root sign or the radical sign. So since the n is the same, we can multiply them and write them as the square root of 7 times times 3, this will give you the square root of 21. Okay, so I've used the multiplication law of Surds. Okay, remember, the multiplication law of Surds can be written from the left towards the right or from the right towards the left. Okay, then B, we have 3 square root of 6 minus square root of 6 plus 7 square root of 6. Now, this one, we have got both addition and subtraction of cells. So, you need to be aware that when you are adding or subtracting cells, it's more like how you do it in algebra when you group the like terms. Okay? So, the square root of 6 in this question here, this square root of 6 is like your x. Okay? That's like your x in algebra. Okay? Now, it is better for me to relate it to your knowledge of algebra because you can better understand it that way. So, treat the square root of x the square root of 6 like x. So, what this means is, I'm going to start by the subtraction first. Okay? Remember, we can start by subtraction or we can even start by adding. It won't make any difference. So, this will be like 3. This will be like 3. Here, there is a minus 1 because of that. Okay? There is a minus 1 because of that. Remember, you have to treat the square root like x or 1. So this is like 3x minus 1, which is more like 3x minus x. So you end up getting a what? You end up getting a 2. Okay? So if I subtract the first one, it will be 3 minus 1, which is 2. But because I've got this square root of 6, it becomes 2 square root of 6 plus 7 square root of 6. Okay? Then here, all I have to do now is just add this 2 and that 7. If I add those 2, I'll get a 9. Okay, and then I'll put my square root of 6. Remember, the square root of 6 is like your x from algebra. Okay, so the way you add and subtract algebraic terms is similar to how you do it with surds. Okay, any question? You can speak if you want. I just need one person to confirm that you are following. Any question?
Sir, I don't understand the second example.
Or you didn't understand the second example? Hello?
Yes. Yes.
All right. What I can do is I can probably do it in a different way, but I may have to use factorization if you didn't understand it from the perspective of adding or subtracting algebraic terms. So I'm going to use method 2. Maybe you understand method 2. So what I'm going to do is do it this way. I'm going to rewrite the question is 3 square root of 6 minus square root of 6 plus 7 square root of 6. Now, let's use factorization. Maybe you can understand it that way. Okay? If you don't understand it from an addition and subtraction of algebraic terms, let's use our knowledge of factorization. What's the common factor here? The common factor is square root of what? 6. Okay? It's a common factor. Why is it a common factor? Because we have got a subtraction here and we've got addition. So we can use our knowledge of factorization from grade 9 and grade 10. Okay? So I'm going to take out that square root of 6. Okay? If I take it out, I have to get the first term inside, I have to divide this by the square root of 6. So the square root of 6 and the square root of 6, which is the factor, are going to cancel out. So I'll be left with a 3 there. Then here I'm going to have minus square root of 6 divided by square root of 6, that will give me a 1. Okay? Plus, here, if I divide 7 square root of 6 by square root of 6, I'll get 7. Then, I now need to simplify what's inside the bracket. 3 minus 1 is a 2. Plus 7, you end up getting 9. Now, generally, when you get to this point when you're dealing with surds, the integer must be in front of the surd. So, I can write my final answer as 9 times square root of 6, which is exactly what I got there. But here I was adding like algebraic terms. Is it better now? Hello?
Yes, sir.
Did you understand?
A little bit, but like, didn't you say that the square root doesn't have a number in front? It means to the square root.
I said, if you have got a square root sign, right? If there is no number outside, like this, if there is no number
Yes.
the number that I'm talking about is the 2 here. We don't write it down. You know this, eh?
Yes, sir.
Yeah, that's what I was talking about. You can only write the number outside when it's a 3, 4, 5, and so on. If it's a square root, that is a 2, you don't write it down. But my question is, did you understand
Yes, sir, I did.
the way that I did it? If you didn't understand the first method, the factorization method, did you understand it?
Yes, sir.
Okay. Okay, I
And
just want.
sir, Nofunda's asking you to let her in.
All right. I want you to be aware that when you're doing the factorization method, always remember that the square root of 6 is like x. So that's like x. It will make things easier for you when you're doing the question. Now, it's extremely important for you to know that factorization is a very important technique that has got applications in other topics in maths. Like in this case, I had to use factorization to do the problem. So your knowledge of factorization is of utmost importance. Okay? So let me carry on with the next example. Now the next two examples, they are a little bit more complex, so make sure you pay attention very carefully. So we have 2 square root of 18 minus the square root of 32. Okay? Now, sometimes you can be given a question like this one, which is not simplified inside the square root. So for you to be able to do that, you have to write every number inside the square root as a product of a perfect square and a prime number. I'm going to repeat that. For us to simplify this question here, we have to write the 18 and the 32 as products of a square root, so of a perfect square and a prime number. Remember, your perfect squares are numbers like 1, but 1 generally we don't consider, we don't usually use it, okay? So we start from 4 as your perfect square. Okay, so 4 is our first perfect square. Then we have got 9, 16, 25, 36, 49, and so on. And your prime numbers are mainly 2, 3, 5, 7, and so on. So I need to rewrite that 18 and the 32 as products of a prime number and a perfect square. Okay, so I'll write the first one and my 2. Then the 18, you have to know your factors. Okay, remember you were taught factors in the lower grades, grade 7, 8, and so on. Now, those factors that you were taught are extremely important when you are doing a question like this. So the 18 I can write it as 9 times 2, right? Minus. The 32 I can write it as 16 times 2. Okay, so I have written these numbers, okay? Remember, that's your perfect square, that's the prime number. That's your perfect square, that's the prime number. So I've written the 18 and the 32 as products of a perfect square and a prime number. Then the next thing, I have to use the multiplication law of sets. Okay? If I'm multiplying two numbers like that, I can split them. Remember, this 2 is multiplying everything inside the square root. So I can write this as 2 square root of 9 times square root of 2 minus the square root of 16 times the square root of 2. Okay? Then when I get here, because the square root of 9, it's an integer. It's a 3. So I can write this as an integer, which is a 3. I can write that as an integer, which is also a 4. Okay? So this will become 2 times 3 times square root of 2 minus 4 times square root of 2. So I'll end up having this 2 and that 2 will give me a 6 times square root of 2 minus 4 square root of 2. Okay? Now, if you look at it here, we have a square root here of 2. We have a square root of 2 and we have a square root of 2, which means we have got two like terms, so we can subtract them. So it will be here, if you want, you can use the factorization technique. Okay? If I use the factorization technique, right? My common factor there is going to be square root of 2. Open bracket, I'll have a 6 inside and a 4. Alright? So my final answer will be 6 minus 4, which is a 2. 2 times square root of 2 will give me 2 square root of 2. That will be my final answer. Okay? Any question? Are you following? Can someone respond? I'm asking a question. Are you following? Okay. Let's do the next one. That's the square root of 32 over the square root of 2. Okay? Now this one we are dividing two sets, but the numerator can be simplified. The denominator is already simplified. So what we can do here is to write 32 as the square root of 16 times 2 over the square root of 2. Then we split it up, we split up the numerator and write the square root of 16 times the square root of 2 over square root of 2. Now because of division, okay, this square root of 2 and that square root of 2 can cancel out. If we do that, we'll be left with the square root of 16, which will be a 4. So 4 will be the final answer. Okay, I've used the division law, and I've also used the fact that if the number inside the square root, okay, is not a perfect square, then I have to try and write it down as a product of a perfect square and a prime number. All right. So let me move on to the next one. Okay, let me move on to the next one. Now, the next one, this one here, is a little bit more complex. Okay, I want you to pay attention carefully how you do a question like this one. Okay, we need to do what is called rationalization, whereby we make the denominator an integer. Okay, now for us to be able to make the denominator an integer, we have to multiply both the numerator and the denominator by the denominator. Okay? You can only understand it better if I write it down. So, that's square root of 50 minus square root of 2 over square root of 8. We can simplify it by multiplying the numerator by square root of 8 and the denominator by square root of 8. We are multiplying by this denominator so that we can create an integer. And that process is what is called rationalization. Okay? We are converting the denominator to a rational number. Remember, you did rational numbers from grade 8 up to grade 10. Okay? All rational numbers can be written in the form A over B. That is, they can be written as fractions. And integers are rational numbers. So this square root of 8, it's not a rational number, but we can make it a rational number by multiplying it by itself and also multiplying the numerator by the square root of 8. So if we do that, we can end up having, my next step will be the square root of 8 times the square root of 50 minus the square root of 2. So what I've done is I have taken this square root of 8 and multiplied it by both square root of 50 and by square root of 2. So I put it inside brackets because this is like a binomial from your knowledge of algebra. Okay? Then my denominator is going to be equal to square root of 8 times square root of 8. So I multiply this square root of 8 by both square root of 50 by both square root of 50 and minus square root of 2. Then I have to multiply the square root of 8 by square root of 8. We do that so that we can rationalize. Okay? Then the next step will be, now I don't want to complicate things for myself, so I'm going to convert this 8 here because it can be written as a product of a prime number and a perfect square. This 50 can also be written as a product of a prime number and a perfect square. So I'm gonna simplify it like this. So I'm gonna write my square root of 8 as square root of 4 times 2. Open bracket. The 50 can be written as 25 times 2. So I'll write this square root of 25 by 2 minus the square root of 2 all over. Okay? Now, check this now. Square root of 8 times square root of 8. We can write that as the square root of 8 by 8. Okay? I don't want to rush to simplify it for you because I want you to see something. Alright? Then, this square root of 4 times 2, I can write it because remember, square root of 4 is a 2. So I can write as 2 square root of 2. Then I'll open my bracket. Right? The square root of 25 times 2, I can write it as 5 square root of 2 because 25 is a perfect square and the square root is 5 minus the square root of 2. Then I'll close my bracket. This is all over. Now check this. Square root of 8 times 8 gives you a 64. So I can write this as square root of 64. And 64 is a perfect square. Okay? From now on, you need to know that if you have got something like this, square root of 8 times square root of 8, okay, the answer is going to be 8. Okay, I've shown you where it comes from the steps up to here. Okay, so my numerator, I can simplify it now. Now, for me to simplify the numerator of that fraction, I have to multiply this 2 by that 5. So I'll multiply the numbers outside the square root, that is the integers on their own. So 2 times 5 will give me a 10. Then, square root of 2 times, okay, let me use a different color here. Square root of 2 times square root of 2 will give me a 2. Okay? Because square root of 2 times 2, square root of 2 times square root of 2 is the same as square root of 4. So what I'm talking about is like this. Square root of 2 times square root of 2 will give you square root of 4, which is equal to a 2. That's what I'm talking about. Right? So, I'll end up having a 2. So I'll multiply that 2 by 10. Because remember, I'm multiplying the factor outside the bracket by the first term inside the bracket. Remember that. Alright? Then minus. Now, 2 times 1 here times minus 1 will give me a 2. Times square root of 2, this one now. I'm multiplying that. Square root of 2 times square root of 2 will give me a 2. Okay, you should know that by now. Right? My denominator will be 8. So when I simplify it, I'm going to get 10 times 2, which is 20, minus 4 over 8. And that will give me 16 over 8. And the final answer will be 2. If you want, you can use your calculator to check the answer. Your calculator can accommodate Surds, so you can use the calculator just to verify your answer if you like. But generally, these questions, you are supposed to do them without using a calculator. You are supposed to do the questions without using a calculator. Is there anyone who has got a question? Is there anybody who has got a question? Is there anyone who has a question? Okay, if you don't have a question.
So there's messages that people ask.
Okay, right, I just saw the messages. Okay, the first one from Samtanda says, say, I don't get the first step. Okay. Can you talk, Samtanda, which step you don't understand? Huh? Which step is? Are you talking about this step or are you talking about that step? Okay, I'm going to assume that you are talking about this one because you don't want to talk. So the basic idea is when you are simplifying sets that are dividing each other, okay, when you are simplifying, you need to make sure that the denominator, okay, is an integer. Remember, your sets are irrational numbers, okay? your surds are irrational numbers. So the objective of doing this, of doing all this, is to make sure that I eliminate the surd in the denominator. I hope you are aware that square root of 8 divided by square root of 8 gives you a 1. So this is just a mathematical manipulation that we use to solve or to simplify this problem. Okay? The rest is knowledge of your algebra, knowledge of your prime numbers, knowledge of your perfect squares. Okay? This is one of the reasons why you had to do algebra, perfect squares, prime numbers in the lower grades, so that you are prepared for this moment. All right? I hope that I've answered you there. Well, in terms of saying, is this the only method? Okay, Dianca, you said, can you do the brackets first and then multiply? Well, you can also do the brackets first and multiply if you want. Okay, there is.
Sorry for the interruption. If we had four black and red, to go down to the draw 190, four black and red.
Okay, there's no special rule. Okay, you can simplify what's outside the bracket first, or you can simplify what's inside the bracket first. For this example, I decided to simplify what's outside. Okay. All right. Let me do the next one. Now, this one now is the last example for today because I want you to digest everything that I spoke about. Right. Now, when you want to simplify something like this, you have to use the conjugates of the denominator. Okay? You want to simplify a rational number like this one here, which has got a denominator which is made up of two rational numbers. You have to simplify it by multiplying the numerator and the denominator by the conjugate of the denominator. I'm going to explain what the conjugate is. Now, use the conjugate of the denominator to simplify. Okay? Now, examples of conjugates. I'm just going to give you this one. If I give you, say, the square root of 50 minus, say, square root of 2. The conjugate of this is going to be square root of 15 plus square root of 2. So the sign here and the sign there must be opposites. Okay? So the conjugate of this square root of 12 minus square root of 8 is going to have a plus there. Right? So this is the conjugate of what? Of that set. So every set that's a binomial has got a conjugate. And a conjugate is just a set with an opposite sign between the irrational numbers. That's all. Okay? So you don't need to get confused there. Then your knowledge of algebra is needed for you to be able to carry on. So I'm going to start by saying the square root of 48 minus the square root of 32. This is all over the square root of 12 minus the square root of 8. Remember what I said earlier in the previous example, that when you are simplifying sets like this, you need to do a technique called rationalizing, whereby you have to convert the denominator to a rational number. Okay? Remember, these sets are irrational. Okay? These sets are irrational numbers. So when we rationalize, we have to convert the denominator to a rational number. To do that, we use conjugates, or we can use the technique that I used here, whereby you multiply the numerator and the denominator by the original denominator of that set. Okay? So here, I just need to multiply this by the conjugate of the denominator, which will be the square root of 12 plus the square root of 8, all over the square root of 12 plus the square root of 8. Alright? Check this. We have got a minus here, but now we've got a plus, and here we've got a plus. If I divide these two, the answer that I will get is a 1. So it's again a mathematical manipulation that you can use. Now, to simplify this, you have to use your knowledge of algebra. This is a binomial. So I'm going to convert the square root of 48 to square root of 16 by 3. And then I'll convert the square root of 32 to square root of 16 by 2. Okay? Right? Then I'm going to convert this multiplication to a bracket. I'm going to replace it with a bracket. So if I do that, the square root of 12 becomes the square root of 4 by 3 plus the square root of 8 becomes the square root of 4 by 2. Then I close my bracket. Okay? That's my numerator. My denominator, okay? The square root of 12, I can, okay, the denominator, I may not need to do it the way that I'm going to simplify the numerator. So I'm going to rewrite this, the square root of 12 minus the square root of 8 times the square root of 12 plus the square root of 8. For now, I'm going to write it like that. Okay? Now, we have to use FOIL now to simplify. But before I use FOIL, I want you to be aware that the numerator, I need to simplify it further. So, I'm going to move on to the next page. Okay, if I move on to the next page, I want you to be aware that square root of 16 is a 4. So, if I move on to the next page, I have to write 4 square root of 3. And I have to put that in brackets. Okay? I have converted this square root of 16 times 3 to 4 square root of 3 because 16 is a perfect square and the square root of 16 is a 4. Right? Then I'll put that minus. Now, square root of 16 is a 4. So I can write the second term inside the first bracket as 4 square root of 2 times the second bracket, the square root of 4, it's a 2. So I can write the first term of the second bracket as 2 square root of 3 plus the second bracket is square root of 4 times 2, which is the same as 2 square root of 2. So I can write this as 2 square root of 2. And this is all over. Now I want you to pay attention carefully now. How I'm going to simplify the denominator. It's so interesting how the denominator is going to become a rational number. So here I have square root of 12 times square root of 12. By now you need to know that square root of 12 times square root of 12 is a 12. Okay? By now you need to know that. So I'll put my 12. Alright? Then square root of 12 times 8. So I have to multiply now these two. Okay? That will give me square root of 12 times square root of 8. I don't need to simplify it, so it will be a positive. Okay? It will be a positive square root of 12 times square root of 8. Then I need to multiply these two. But remember, there's a minus here. So it's going to become minus square root of 12 times square root of 8. So I'm going to write this minus 12 times square root of 8. Then the last term, okay, is going to be minus square root of 8. It's this one here. It's going to be minus square root of 8 times positive square root of 8. Now that will give us a negative square root of 8 because of that minus. Okay? So I'm going to end up getting this minus 8. Like that. Now check this. The denominator, okay? The denominator, because of this plus and that minus, this part is the same, that part is the same. That's square root of 8, that's square root of 8. These two are going to cancel out. Okay? Because they are like terms. So when they cancel out, my numerator, I can simplify my numerator now and say 4 times 2, that will be 8. Square root of 3 times square root of 3, that will be a 3. I'm simplifying the numerator. Then, if I multiply, so I multiplied these two first. Then, now I have to multiply this one here and that one. So 4 times 2 is going to give me 8. So I'll end up having positive 8. Then square root of 3 times square root of 3 will give me square root of 6. Then I need to multiply this one here by that. So minus 4 times positive 2 will give me a negative 8. Square root of 2 times square root of 3 will give me square root of 6. And then the last part, it will be multiplying that by that. So minus 4 times positive 2 will give us minus 8. Square root of 2 times square root of 2, that's a 2. So this is all over. Now here in the denominator, I'm now left with this 12 and that 8. But the 8 is negative. So my final answer in the denominator is going to be 12 minus 8, which is a 4. Now I need to simplify further that numerator. Okay, 8 times 3 will give me 24. Now if you look at it here, you find that there's a plus here, there's a minus. The 8 outside the square root is the same, the 8 outside the square root. We've got a square root of 6, square root of 6. So these two are like terms, they cancel out. Okay, so I'm left with minus 8 times 2, which is 16 over 4. So you end up having 8 over 4, which means the answer is going to be a 2. And then you're done. So what I've done here, I've done a process called rationalizing, using my knowledge of the conjugate, my knowledge of algebra, my knowledge of prime numbers, my knowledge of perfect squares. You need all that. Okay? All right. I've got another lesson, so I have to stop now. Okay, thanks so much for taking part. Right, if you've got any questions, okay, I would suggest that you probably may ask me tomorrow, but I'm going to give you some homework to do today. Right, okay, you can watch the video later again if you want. Thank you so much.
Thank you, sir.